Okay, good afternoon. I'll be discussing about analysis of continuous beams by using theorem of three moments with supports sinking, either one support or two supports. Okay, sinking of supports. How it affects the moments. How the equation changes for beams with sink. Okay. Yeah. Now consider a two-span beam ABC fixed at both ends. So now, if support B sinks down, okay, support B sinks down. Let us suppose, okay, support B sinks down by some amount, okay. With respect to A and C, with respect to A and C. Here, the relative sinking is important because all the supports may sink, but B may sink more than the supports A and C. Okay, here the relative sinking we consider. Let us here first consider support B sinks and A and C remain in the original position. Okay. Okay. Let that be delta sinks down by some amount. What does this mean? So here initial position is this ABC and B sinks down. A also may sink down by some amount. Okay. A also may sink down. So here delta A is the difference in elevations of supports A and B. Delta C is or height of support C above B, support B. Delta A is height of support A above. We are not going to see the derivation for this. We will see directly the expression. Okay, the three moment equation considering the sinking of supports. Okay, without sinking and with the constant EI, this is the equation. Okay, if flexural rigidity is different, then it becomes MA L1 by I1 and so on, isn't it? That we have seen already. Variable flexural rigidity, variable EI value. Okay, now due to sinking, the equation changes. The three moment equation takes this form. That means here the terms 6EI delta A by L1 plus 6EI delta A by L2. Yeah, these two terms are added on the right hand side. Okay, derivation part we are not going to discuss. Okay, as we have already mentioned, delta A and delta C are the height of support A and support C above support B. Okay, here the sign is important. Sign of delta for the left and right supports, that is important. Okay, so how it is taken? Positive for higher and negative for lower. Okay, yeah. Considering continuous beam ABCD, if the support B sinks down by an amount delta, okay, three supports namely A, C and D will remain at the same level. For example, B only sinks by delta, remaining three supports. Okay, they remain at the A, C, D remain at the same level. Okay, while using three-moment equation for AB and BC, for AB and BC, the values of delta A and delta B will be positive because both A and C are above B. Both the supports A and C are at higher elevation than that of B. That means the common support, common point. So this elevation difference is measured from common support. Okay, that is B. For example, if you apply the same for BC and CD, BC and CD, then common support is C, and here with respect to C, B is below. B is below. So delta B will be negative in that case. Okay, and delta D is 0 because there is no sinking of support D. C and D are at same elevation, so delta D will be 0. So you have to keep this in mind while applying this equation. Okay, proper sign we have to consider. Okay, so this elevation difference, delta A or delta C, whatever it may be, it is considered from common support. That means when you consider AB and BC, the common support is B. When you consider BC and CD, the common support is C. For BC and CD, the common support is C. So with respect to the common support, the elevation difference is measured. Okay, if below, negative; if above, positive. Okay. Now let us consider some examples, numerical examples. Yeah, consider the beam ABC, continuous beam, with the support B sinking by 5 millimeters. Okay, support B sinking by 5 millimeters, and subjected to uniformly distributed load of 50 kilonewton per meter over entire length. And let EA be the constant throughout the beam. Okay, and E value is 200 gigapascals. I is 332 into 10 power 6 mm power 4. Find the bending moment at supports A and B and draw the bending moment. Bending moment at A and B, because bending moment at C is 0. Being simple support, bending moment at C is 0. So the unknown moments are MU and MB. Two unknowns we have and two equations we need. Okay. Yeah, as we have already discussed, when we have fixed support, then we will assume a 0 span by the side of fixed support. Here to the left of A, we consider AO of span L0, which is 0. Okay. Now we apply the three-moment equation first for spans OA and AB, and then for spans AB and BC. Okay. And here L1 is span of AB, length of AB, and length of BC L2. Okay. And sinking of support minus 5 millimeters. So here delta A, delta C are plus 5 because when you consider AB and BC, the common support is B. So delta A and delta C will be positive because they are above the level of B. But when you consider OA and AB, the common support becomes A and delta B will be negative because it is below the common point A. B is sinking down, isn't it? So delta B will be negative with respect to the common support because it is moving down. Okay. So this is the final bending moment diagram. We'll see this later. So let MA, MB and MC be the fixed moments, and MC is 0 here, we know that. And mid-span moment will be WL1 square by 8, and for span AB, and WL2 square by 8 for span BC. So here we get 156.25. Okay. W is same for both, 50. L1 is 4 and L2 is 3. Okay. So the moments at mid-span for AB and BC are 156.25 kilonewton meters respectively. Okay. Now we draw the new diagram. What is new diagram? For span OA, we will be applying this for first A1, that is OA and AB, isn't it? So here the common support is A. So on OA there is no load and no new diagram. On span AB we have UDL, so its span moment will be 100 maximum, which is a parabola. So here A naught means new diagram over OA, and A1 is area of new diagram over AB. And x1 bar, x0 bar is from O and x1 bar is from B. Okay, when you consider OA and AB, x1 bar is measured from B end supports. These distances are measured from end supports, not common support. Okay. So here area A1 is 2/3 BH, 2/3 H is 100, base is into 2 centroidal distance x1 bar. This is area and this is x1 bar. So it comes out 533.3. Okay, A1 x1 bar. A0 x0 bar is 0 because area is 0. And for spans BC, AB and BC now. AB and BC. So here it is again a parabola with 56.25 coordinate bending moment at midspan. So when you consider these two spans, AB and BC, then x1 bar is measured from A and x2 bar is measured from C. x1 bar is measured from A and x2 bar is measured from C. End supports. Okay? And what is A1 x1 bar? Just now we have calculated, which is 533.3 because it is symmetric. And A2 x2 bar is same. Area is 2/3 BH and distance centered comes out 168.75. Now we know all the values. So substitute first in the equation. The equation, three-moment equation for spans OA and AB is this one. M0 L0 plus 2MA into L0 plus L1 plus MB L1. Here L0 is 0. Okay, this term becomes 0. And here L0 is 0. So finally we have 2MA and L1 is 4. So 8MA plus this is L1, 4MB. 8MA plus 4MB. And on the right hand side, this term is 0. Okay. And how about delta naught? Delta naught is 0. This term is also 0. And with respect to common support, okay, this term will be 0. And delta B is minus 0.005. And we find EI value. What is EI value? E is 200 into 10 cube kilonewton Newton per mm square. Okay, 200 gigapascals it is given. That is 2 lakh mega 2 into 10 power 5 megapascals. That is Newton per mm square. And I value 332 into 10 power 6. So this you will get in Newton mm square. To convert it into kilonewton meter square, we will multiply with 10 power minus 9. So this value, whatever you get here, multiplied by 10 power minus 9, converts the units to kilonewton meter square. This clear? So that EI value will substitute here. So 200 into 332, 10 power minus 9 plus 9. Yes, 332 into, that means 66400. This is the EA value. 66400. Now substituting the values, we will have 8 MA plus 4 MB equal to 6 A1 X1 bar. First term is 0. A1 X1 bar we have calculated it's 533.3 by 4 into EI. Just now we have calculated it as 66400. Otherwise, you write E and I. Delta B is minus 0.005. Why minus means? From common support A, B is below A. Is it? By 0.005 meters. Okay? Yeah. So, we will get this equation. Okay? Now again, apply this for spans AB and BC. The equation is now MAL1 2MB into L1 plus L2 plus MCL2 is equal to minus 6A1 X1 bar by L1, 6A2 X2 bar by L2 plus 6EI delta A by L1 plus 6EI delta C by L2. Here delta A and delta C are positive because they are above common support B, because B is moving down. Okay, so C and A are above B. Okay, so both delta A and delta C are equal to plus 0.005. Okay, so on the left hand side you will have 4 MA plus 24 MB. 4 MB plus 24 MB. And on the right hand side, if you calculate that, is it 14 MB? Yeah, 14 MB, not 20. 4 plus 3, 7 into 14 MB. 4 MA plus 14 MB or 2 MA plus 7 MB equal to 12.2. This is second equation in MA and MB. Solving these two, first equation is 2 MA plus MB and here 2 MA plus 7 MB. So by subtracting 1 from 2, you will get MB 56.1. Substituting this in 1 or 2, you will get MA minus 194.3. Okay. So now to draw the bending moment diagram, at A it is minus 193. Okay. At B it is 56 plus. Okay. Your plus minus means plus means clockwise you will have. Here you will have anti-clockwise. So both are negative when you consider bending moment diagram. Is it? Both are hogging in nature. Both are producing hogging moment. So both are negative value. Here you have positive value 56 point, but positive means here it is clockwise. So Here clockwise means it is hogging only. So it is negative bending moment. Okay, 56.1. And here at here bending moment is 0, being simple circle at C. And this is the fixed bending moment diagram. Superimpose on this the free bending moment diagrams due to UDL. Okay, so the net bending moment diagram will be this. Net bending moment diagram will be this. This is positive. Okay, this can also be drawn like this. Yeah, this. Okay, this. I think we made a mistake here. Correct that one. Bending moment diagram. This minus or positive. B is positive. 7MB. So the first equation here is 2MA plus MB. 2MA plus MB equal to minus 320. 6MB equal to 336. MB is 56. Positive. Okay, that is correct. Now we will see another example in the next session. For now, I am concluding this. Okay. We will discuss some more examples in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.